this video, we will show how to set up and use Rapid Spar. In front of us is a standard Rapid Spar kit with the optional adapter set. This includes the user manual, Rapid Spar device, standard cables and adapters for SATA and IDE drives, optional adapters for less common interfaces, and power supply. Everything fits inside an aluminum carry case, making it easy to use Rapid Spar for on-site work. There is even an empty slot for a 3.5-inch target drive to store recovered data. Inside the Rapid Spar device is an interchangeable 120 gig Kingston SSD used to hold the logs and project files for every case. This ensures that we can pause and resume the recovery process at any time without losing any progress. We can now connect Rapid Spar to a USB 3 port on your PC. Rapid Spar will appear in Windows as a USB mass storage device. All we have to do to install the software and activate the unit is launch RSA Setup. Copy the licensing information from an automated email and press the Software and Firmware Upgrade button. In only a few minutes, we are ready to start our first recovery. Here we have an Hitachi laptop drive. Connecting it to a computer does not produce any results because this drive is not capable of identifying. Now, let's try it with Rapid Spar. We begin by connecting a healthy drive to the target port, the patient drive to the source port, and the power supply to the Rapid Spar unit. We can do a full sector-by-sector clone using the standalone Rapid Spar device by pressing the Start button on the touchscreen display. All other functionality is available from the Rapid Spar Assistant Windows software, which we will launch now. The first step is to run the drive through cloud-driven Rapid Nebula Diagnostics. All we have to do is provide basic information about the drive and press Start. Over the next few minutes, Rapid Spar will test the drive and send the diagnostic information to Rapid Nebula for analysis. Rapid Nebula will then send back a diagnostic log, which we can see later. This drive is not capable of identifying, but we do have access to its CPU, ROM, and firmware. The defect lists are corrupted, so this is a good candidate for firmware repair, which we will launch now. The only setting is for the maximum level of risk that we are willing to accept for this recovery. Choosing low risk will only apply temporary solutions loaded into the drive RAM. Medium and high risk options will also include solutions which will make permanent changes to drive firmware. On this drive, both copies of the grown defect list are corrupted, causing the entire translator module to fail and all data to be inaccessible. The Rapid Spar device reads both of those corrupted copies and sends them to Rapid Nebula, where they are assembled into one integral copy. The repaired grown defect list is then downloaded to the Rapid Spar device and loaded directly into drive RAM to restore access to data. Now that data is accessible, we are ready to start a new project and begin recovering the drive. All sectors read from the source drive will first be saved to the healthy target drive, and only then sent to the host PC for analysis. All secondary requests for the same sectors will be automatically served by the healthy target drive, ensuring that we read each sector from the damaged source drive only once. As soon as we start a new project, Rapid Spar will discover the master boot record and partition tables, displaying any partitions that it was able to find. At this point, we can choose to clone all sectors in use by the file system. This clone will be bootable as long as bad sectors do not prevent us from recovering critical system software elements. Alternatively, we can load the file tree and recover only specific files and folders. During this process, Rapid Spar is recovering and parsing all file system elements of the selected partition. This metadata is required to display a file tree and target specific files and folders for recovery. Supported file systems for this functionality include NTFS, HFS Plus, EXT2, 3, and 4, XFS, FAT32, and XFAT. Whenever the recovery process slows down, we can look at the RapidSpar device to see exactly what is happening. In this case, there are many bad sectors within file system metadata, and the drive starts to click whenever it hits them. By default, RapidSpar will retry failed block reads sector by sector to retrieve any good sector within every bad block. This is appropriate for most situations. However, in this case, the drive is in very poor condition and could easily suffer a complete failure before we recover enough data. To reduce the chances of this happening, we can make the recovery process much lighter by changing the way RapidSpar processes bad sectors. The Skip Bads option will instruct RapidSpar to cut bad sector processing at an earlier point and never retry bad blocks sector by sector. This option greatly speeds up the rate of processing of bad areas, thereby reducing the level of stress applied on the drive. The drawback is that we will leave some good sectors behind, so it should only be used on time-sensitive recoveries or on drives which would otherwise be unlikely to survive the recovery process. The file system metadata of our selected partition has now been recovered. We can select particular files by using the search function, or by manually checking the box next to files or folders we want to recover. For this case, we will recover the user folder. We can check this box to automatically skip any files with bad sectors in them. This means that RapidSpar will stop recovering a file as soon as it finds a single bad sector within it, which saves a lot of time and reduces drive stress. We can also skip files manually. For example, right now, we can see that it's trying to recover a file, but every block is failing to read and the drive makes loud clicking sounds. At any time, we can skip the current file and move on. Now that our files are recovered to the target drive, we can have a look at their integrity status. Every file with at least one bad sector in it will show as corrupted. Some of these files could still be usable depending on the type of file and level of corruption. We can open them to check. Finally, we can save recovered data to any folder accessible by this PC to complete the recovery process. Thanks for watching.